Hello, my name is Miranda and my team members are Miranda Romo, Mauricio and Cory, and today we are going to show you the race car competition of Prepatec 2019. Now I'm going to show you how we build our car. First step, we recycle a seat to fix cars and we use it for the base. Step 2, we glue two pieces of wood with the help of a drill and screws. Step 3, we glue the wood to the base with the help of some cinchos. Step 4, we weld the tires to some screws. Step 5, we put some bars on the base in the front and back. Step 6, we made the steering wheel without direction with the singing of a T. Step 7, we place the tires on the bars. Step 8, we bake up the car.
Potential energy is the energy that has an object that isn't moving. It's like when you have a car in a hill and it's there, it has potential energy. But the moment it starts moving, it has kinetic energy.
We can explain the law of the conservation of the mass, saying that when a chemical reaction is carried out, the mass is not created or destroyed, it is only transformed. This is, the reactants, when interacting with each other, create new products with different chemical and physical properties different from the reagents.
We will now talk about the calculations that were involved in our race. So for starters, we want to find our velocity, right? So we know that the distance that our car covered was 10 meters, and it did this in 9 seconds. We can double check that from the video. Therefore, it would seem that our velocity is 10 meters per 9 seconds. So now we will attempt to calculate this velocity, but using a different method. So we'll take into consideration that our mass was of 30 kilograms, the gravity constant is 9.8, and our height was around 5 meters. So using this information and this formula, that total energy is equal to kinetic energy plus potential energy, we will be able to find out this value. So let's take the case into consideration where our kinetic energy is 0. So our car has not moved. We have kinetic energy is equal to 0. So our total energy, say E1, which is 30 kilograms, times our gravity constant, 9.8 meters per second squared, times 5 meters, which is our height. And then let's take into consideration the case where now our potential energy is 0. So from this we can gather that E2 is equal to 1/2 times 30 kilograms times V squared is going to be equal to this energy. We also know that energy preserves itself, so from here we can conclude that E1 is equal to E2. So from this we gather that 1/2 of V squared times 30 kilograms is equal to 30 kilograms times 9.8 times 5 meters. We both sides, we have a 1/2 here, we can multiply, we can send it here, multiplying it by 2. We get that V squared is going to be equal to 9.8 times 5 meters times 2. 5 times 2 is 10, 10 times 9.8 is going to be equal to 98. And we want the square root of this, so we have that V is going to be equal approximately 9.9 meters per second, which is a very different value from what we have here. As a matter of fact, this will be slightly more than 1, and this is a lot more than that. So now the question arises is, why are these two values so different? And the answer lies in friction. During this process, we never took into consideration the force of friction, which is a force an object ejects on the other one when this object is sliding on top of a surface. So, in other words, friction is a force that can alter movement, and therefore it will alter our velocity.